think I'll go ahead and get started. So welcome everyone. So glad to see you here. You're here for DevOps in the Cloud. This is about Amazon.com teams and their resilient architectures. I personally like learning by example. Give me an abstract concept. I'll struggle with it. Give me a concrete example. I get it. So I love sharing real examples. Plus, you're going to get a bonus use case today also. My name is Seth Eliot. I'm currently the principal resilience architect with RPO, but I spent 14 years at Amazon. I was previously in AWS as the global reliability lead. And in that role and other roles across AWS and Amazon, I worked with hundreds, maybe more, of Amazon teams and their AWS adoption, AWS modernization. So I draw upon that to share these stories with you today. And it wouldn't be a good DevOps talk without the wall, right? I think we all know what the wall is, but just so we're all on the same page, that is the wall that traditionally has existed between development and operations. It's the wall that prevented communication. I see someone taking a picture of the wall. That's awesome. And it prevented these teams, these roles, I should say, from having shared goals. Development had the goal of get stuff out fast, get new stuff out there. Operations had the goal of keep it stable, keep it available. These two things tended to clash sometimes. So breaking down the wall is really what DevOps is about. And if you're going to break down the wall, one way to do that is with how you organize your teams. And that's sometimes called the team topology. There are multiple different topologies that work with DevOps. I'm going to share with you today one topology, the one that Amazon uses. It's the one that Amazon uses. I'm sharing it with you. I think you can learn from it. That doesn't make it the right one or the only one, but it is one way to do things. And here it is. It's based around the concept of the two pizza team. Two pizza team is a cross-functional team at Amazon that owns one or more services. And they own it all the way through the life cycle, from design to code to build to deploy to operations. They own the whole thing. There's no separate operations development roles. It's just one role owns it all. A two pizza team is typified by that tight ownership that I was talking about, where they own one or more services and nobody else can touch those services. Also typified by broad autonomy, giving teams the ability to do what they need to do. On a two pizza team, you choose the technology you're going to use to build the service. You choose the language, you choose the tools, all within the broad guardrails of Amazon, like you have to adhere to security standards, for instance. But within those guardrails, you're free to choose whatever you want. The thing to keep in mind is this is not just a development team. It's a multidisciplinary team. It's got development and product. They may not report to the same manager, but they're on the same two pizza team. It's also got QA. It's also got UX designers. Everybody you need to build and own this service. And there, I just gave you the answer. Have your team own everything, right? And all of you should be thinking, oh, you just made my life a lot harder, didn't you? Because now we're asking every team to worry about build and deployment and operations and figure out which tools they're going to use and implement those tools. That's all undifferentiated work, right? The value added work is features and bug fixes and new products, right? Figuring out how I'm going to build and deploy, that's undifferentiated work. It's sometimes called undifferentiated heavy lifting. And I've just now assigned this to all your teams. Congratulations, reinventing the wheel. So ultimately, that statement about a two pizza team owning everything end to end is a cultural one. It's a statement of a culture. And DevOps is all about culture. I want you to keep, if there's one thing you take away from today, that DevOps is about culture and the tools are based on that. The tools come after that. So in order to enable the culture you want, in this case, complete ownership from beginning to end, you need tools in place that are going to reduce that burden and reduce that undifferentiated heavy lifting. Which brings us all the way back to two pizza teams and teams. The goal of today's talk, the focus of today's talk is about teams and frameworks. A framework I'm defining as something that helps a target audience solve a specific challenge. So it's a tool or tools. And I'm going to say that it will work the best when there's another team, a two pizza team, that either owns that or has accountability for that. Like not everybody's just going off and using the framework or the tool, but there's a team behind that tool that's responsible for maintaining it, for operationalizing it, making it useful to the target audience. So bring it back to the Amazon example. In general, actually bring it to the general example, when I say tools, I obviously mean open source. We're at an open source conference, but I also mean third-party commercial and build it yourself. They're all valid tools. I mean, open source certainly is a great choice, and I would lean towards it, but it's not the only choice. And when you look at Amazon, they've actually chosen most often to build their own. And why is that? Number one is Amazon's old, right? So in 1998, when they needed to create a deployment pipeline, there maybe weren't that many solutions out there, so they built their own. That doesn't mean Amazon doesn't revisit those decisions. When I left Amazon in 2009, came back in 2014. When I left in 2009, they were using Perforce for their code repository. When I came back, they were using Git. So they evolved, they went to open source. And true to the whole frameworks approach, Git was embedded in a framework called Brazil that's still used today. And the other reason Amazon tends to build its own is just the scale of Amazon. That is the architecture of Amazon.com. Each dot on there is a service, and the lines between the dots, if you could see them, are the lines of dependency. It's truly insane. Thousands of thousands of services running on tens of thousands of servers. And I look at this diagram and I wonder why it just doesn't implode or collapse. You look at that and you wonder, how could that even work? And that brings us back to two pizza teams. Each dot, each service on there is owned by a two pizza team that has accountability for it. And then a group of dots in an organization are owned by their organization. It's sort of fractal, which are then owned by a department. So that by that tight ownership, this can work. Which brings us to our first case study. It's going to be a shorter one. The other ones will be longer, I assure you. But the first case study is about the Amazon detail page. The detail page, who here has used Amazon.com? Who here is not going to raise their hand no matter what I say? All right. You've all used Amazon.com. Whether you still use it or not, you've used it at some point, right? And you went to a detail page to buy something. Detail page is where the images, the price, the description, everything you need, the reviews about an item. And the detail page is enabled by a framework built by the buying experience team. And let me tell you what that looks like. So if you work for Amazon, like I used to, you can go to an internal tool and bring up any detail page with this debugging tool in place that'll show you that every element on that page is being supplied by a different microservice. They call them widgets. So you see there's a title, an image service, there's a title service, there's a byline service, there's an average customer review service. Hundreds of these calls being made in parallel by the framework provided by the BuyX team. And there's requirements before you can onboard a widget. You actually have to adhere to the requirements of the framework. I remember this is a long time ago and it may have changed, but like when I was on the Prime Video team, like circa 2008 or so, I was creating a new widget for the detail page. And the number one requirement, do not add any latency, like literally 0 milliseconds of latency. If you added any latency, you are not going to be included. So there's rules about what you can do, but this decouples the presentation layer from the business layer and leads to several benefits. So you'll see these boxes that pop up periodically. They're the benefits or resilience benefits. Independent development and deployment. Number one is, so if I have business logic I need to provide on the detail page, I don't have to wait for other people to do work. I just update my own widget, independently deployable. The other advantage is something called graceful degradation. It's going to come up again and again, so let me explain it to you. So graceful degradation says instead of going down and being unavailable, we're going to degrade the experience a little bit, but remain available. So that means in this case, let's say a widget dies or doesn't work, and it's not the title widget or the price widget or the image widget. I could still go to my detail page and make a purchase, right? So I'm in a degraded experience, maybe a very minorly degraded experience, but I'm still available. So graceful degradation allows you to remain available. Okay, I told you that was a short one. So case study number 2 is going to be about Amazon search. To get to that detail page, you probably went to Amazon search. Now, in my case, I'm going to search for, I don't know, chaos engineering? Yeah, I'll search for chaos engineering. Oh, I got over 1,000 results. Oh, big surprise. Yeah, I mean, you get a lot of results, and search is definitely a high scale system, right? It's got 300 million active users, at the last time I had access to the statistics, hit 84,000 requests per second at peak. This is a large scale system. And they want to do chaos engineering for search. So what is chaos engineering? Okay, here's the definition. This is the only time I'm going to read from a slide. Chaos engineering is the discipline of experimenting on a system in order to build confidence in that system's capability to withstand the turbulent conditions of production. I think if we're all software folks here, we all understand what turbulent conditions of production are. It's a mess out there, honestly. But what chaos engineering really is about is about taking a scientific approach to understanding your resilience. You built your app to be resilient. You expect it to react in certain ways when faults happen. But how do you know they're going to react that way? You inject the fault. That's what chaos engineering is about. Injecting fault in a risk mitigated way to understand how your system responds. And this is what Search wanted to do. Now, Search is over 40 backend services, each owned by their respective two pizza team. But there is another team in Search that doesn't own any of those services. This is the Search Resilience team. Again, teams owning frameworks. Search Resilience is responsible for driving resilience of Amazon Search. The two pizza team responsible for that. And in this case, we're going to talk through how they enabled Search to do chaos engineering. And when talking about frameworks, I don't think I mentioned this earlier. I don't think I made it super clear. You don't want to reinvent the wheel. I said don't reinvent the wheel, but you don't want to reinvent the wheel. You want to use existing tools where you can and maybe stitch them together in different ways that make it easier for your target audience. So it makes sense to look at the AWS Fault Injection Service, which is a chaos engineering service that AWS provides as a starting point if you're going to enable chaos engineering across Search. And that's what they did. But just to give you the brief overview of what Fault Injection Service does, it lets you define experiments. You see experiments on the right. And an experiment consists of your actions, the fault you're injecting. Let's say I'm killing EC2 servers. Your targets, I'm killing EC2 servers with this certain tag or in this certain subnet. And then this is the important part that makes it chaos engineering. You have guardrails and safeguards in place. And these often take the effect of a metric or something you're measuring that if it starts going into the yellow or the red, you're going to roll back the experiment because you're having negative impact. Man, you want to do this in a risk mitigated way. So having those guardrails in place is actually essential to any chaos engineering experimentation. They tell you when the experiment's going wrong and let you fix it before it affects anything, affects any customers even. So chaos engineering across Search, they wanted to do various types of faults that Fault Injection Service supports, like they wanted to drain their containers from one of their nodes. They wanted to kill the node altogether. They wanted to inject latency. They wanted to turn off a port and not have it accept traffic, things like that. And the list goes on and on. That's just a few of them. They also wanted to do experiments that FIS didn't do, like load testing or emergency lever actuation. And if you're asking what is emergency lever actuation, I will get to that. But FIS doesn't do it, so I'll get to that. So really, I will drop my and I lost the batteries. Oh, cool. This is being recorded. Did I mention that? All right, we'll go to the manual thing. I can't leave the podium anyway because of the microphone, so I'm already good. I'm good. All right. So when they wanted to enable chaos engineering across 40 plus search services, they were looking at the following requirements. At the center was Fault Injection Service, but also they wanted to do other kinds of events. That's what I just talked about. And the other requirements were as follows. They wanted to present a graphical interface, like a very simple one, nothing fancy, a graphical interface to the experiments, to launching them, monitoring them, but also a programmatic interface so the teams could onboard. They wanted it to run on a certain schedule, which actually at the time they built out what they need, built this framework. FIS did do that, but it was a little bit, you had to stitch it together yourself. FIS has since improved things, so they probably wouldn't include this as a requirement now, but back then FIS didn't do it natively. They wanted to run as part of the pipeline, as part of deployment. Again, FIS will let you do that by creating the proper integrations, but guess what? Internally, Amazon uses its own Amazon pipeline system. It's not an external tool at all. So to integrate with that is its own deal. So by doing the integration as part of the framework, they could save teams a lot of trouble. Okay, this is maybe the most important one here. They wanted consistent guardrails. We already talked about guardrails or what prevent the experiment from going awry with using SLOs. Service level objectives. These are actual things you measure to tell you how well your service is doing. And guess what? The Search Resilience team had, prior to creating the chaos engineering framework, prior to that, created a system for storing SLOs for every team. Every team in Search had to define one or more SLOs, and they were tightly monitored. So that gave them a great way just to integrate with that existing SLO system and say, those are now the guardrails for any experiment we do. And on cord. So this is from the Toyota production system, from the car factory. Anyone on the factory floor could stop the line by pulling a little cord if they saw a quality issue. Very empowering. In this case, it means anyone across search can stop all experimentation if there's a problem going on. And creating search-specific metrics and insights. Of course, FIS emits its own metrics and insights, but they wanted to create reports across all 40 search teams to give to the search management. And this is what they built. All right, as you can see, FIS, Fault Injection Service, is up there on the right, sort of at the center of it. To the right of that, those are just supposed to be representing the search services, 2 out of 40 that we're injecting fault into. The big box on the left is what they built. They built the search orchestrator. And it has all the things we talked about. You can see there's an API, there's a scheduler, there's configuration, there's an andon cord capability that actually just wires right into the guardrail capability of FIS. So by building this orchestrator, they will make it easy and meet all those requirements on the previous slide, make it easy for all 40 teams to adopt KS engineering, which they ultimately did. Oh, and of course, in DevOps, we talk about continuous experimentation and learning. That's really what this is enabling here. It's enabling continuous experimentation and learning about your resilience posture. Oh, emergency levers, right. So what's an emergency lever? Well, that's something used across Amazon. It's not limited to search. And it's a rapid process that allows the system to recover when it's under duress. So for example, this is what search looks like when you search for Lego. You see, it's a pretty rich experience. But if search is starting to falter, maybe starting to brown out, we're seeing some services have problems, they could pull the emergency lever and it will turn off non-critical services. Only the critical services are now running, and those are the ones now you have to keep running, and now you get that experience. This is graceful degradation all over again, right? The customer still can do search, they're just not getting the fancy experience, and rather than search going down, search stays available. So that's graceful degradation. An emergency lever is actually implemented by a framework built at Amazon for all teams to use. That's yet another framework. Case study number 3 is the Amazon Relay app. And this is the app used by the long-haul truckers. So you've seen these big rigs on the road here, especially in the US. They're carrying merchandise between different Amazon warehouses or between vendors in warehouses, between all kinds of points of presence. How do you actually tell them where to go and when to go there? There's an app for that, right? So if you have an iOS or Android phone, you can download this app right now. Now, unless you're a long-haul trucker, you're not going to get very far. I downloaded it and then I wanted my trucker license, blah, 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 and I didn't have one. If you have one, feel free to use it. Let me know how it is. And the app does several things. It'll tell the trucker where to go, which warehouse to go to, when to go there. It'll give them a QR code to get in the gate, tell them what to pick up, where to take it there by, directions to get there, messaging. It's all embedded into the app. I like to think of it this way. There's a super sophisticated program that Amazon's developed over the years for its hundreds of warehouses and millions of items about which item needs to be in which place at a given time. This is a computer program and it's totally abstract until you make it real. And the way to make it real is through this app. Through this app, that sophisticated model is now telling truckers to take this load of stuff from point A to point B, and it makes the model real. And it looks like this. So where the arrow's pointing or the back-end modules are, they call them modules, they're basically just back-end services. And each module corresponds to a functionality that I just named, like navigation or load pickup or gate pass. Each module has one of those, through the app, through the API, says I'm calling the gate pass API, which calls the gate pass module, and it gets the gate pass, right? And in front of each module is a gateway service. That gateway service provides a single point of externalization for the mobile devices. And it also does authentication, as you can see on there. And the thing about this is that these share nothing with each other than an interface, right? So they don't share infrastructure, they don't share code, they don't share configuration, they're all independent. So it's sort of like the detail page all over again. Plug and play different modules, provide the proper configuration, follow the right API protocols, and you should be able to provide that functionality to the end users. And it's a framework itself that provides this functionality. But I also wanted to talk about how they wanted to improve resilience. They wanted to go multi-region. So they're operating in AWS, no surprise, and they're operating out of a single region. And they found that going multi-region would improve their resilience. That's because sometimes regions have problems. I think we've all seen that, right? And this is true of all cloud providers. Every single one will have some sort of issue in a region that a service isn't working or a network is acting flaky, and it's hard to or difficult to operate in that region. So this gives them the ability to fail over to a good region. But even more than that, they wanted to run in an active state, both regions at the same time. This gives them performance benefits. If you're a truck driver on the West Coast, you're likely to be routed to the West endpoint. If you're a truck driver on the East Coast, you're likely to be routed to the East endpoint, and you can get faster turnaround times, lower latencies. So for every, this is an independent, this is a module, one of those backend modules, one of those dozen or so backend modules, and each module is owned by its own pizza team. And the Relay App org decided they were going to go multi-region, but they decided to focus on what's important. And not every module is going to go multi-region, only the critical ones. So if you're a two-pizza team that owns one of these critical modules, you're responsible for coming up with an architecture to go multi-region. And this is a simple version of what that might look like. You might be running serverless on Lambda, in which case you're going to have to be able to stand up that Lambda function in each region. You might be using DynamoDB, which is a NoSQL database, in which case you can use DynamoDB's native global tables functionality, which will replicate data across regions for you. And now you have a multi-region service in East and in West. And when you put it all together, the gateway, the API gateway in front, also went multi-region. So it's an East and West region. And this is what makes it indeed active-active. A given request is going to go to East or West based on proximity or latency, and then call the backend modules it needs to call to finish its functionality. But in the case of, let's say, US East 1 is having problems, and the Relay App team determines, okay, we're going to fail over to the West region, what does that look like? Well, you can see that they're going to turn off the East endpoint. So now all requests are going West. And you can see module A there, the one on the top, it's going to go through the West region of the API gateway, and then through the West version of module A. And that's pretty much guaranteed to be up and running, because if there's a problem in East, it's not going to affect West. So that functionality is critical. It's going to be working. Module B is an example of a non-critical functionality. Let's say turn-by-turn directions. The app provides that, but a truck driver can get that elsewhere, right? So in that case, it's still going to call the East version of that, because that's the only version of that. And one of two things is going to happen. Either it's going to work, because just because they failed out of East doesn't mean East is hard down. That doesn't happen, right? It's never happened. So it just means they failed out of East because they were seeing some issue there they didn't like. But so the turn-by-turn directions might still work, or they might fail. And if they fail, what is that again? That's graceful degradation, right? That's saying, okay, I have the critical stuff, like where to go and what to pick up and where to take it, but I don't have turn-by-turn directions. I could still operate here. And each one of these modules and the gateway are all built by separate two-pizza teams and separate AWS accounts. And this is the other framework story here, which is Builder Tools, which operates across all of Amazon, provides the ability for two-pizza teams to vend AWS accounts, to set up those Amazon pipelines I told you about. It provides testing frameworks in those pipelines so you can add testing, and gives them deployment tools for deploying, right? So by providing all of these tools, that's how the Relay App team was able to do what they did, build this decoupled, modularized architecture and put it in multiple regions. Oh, that's all stuff I already said. Oh, well, I guess the one thing I didn't say is also now they have the ability to fail over to good, right? So if they're in a region that's having problems, they can fail over to another region and continue operating. And it doesn't end there, right? So all infrastructure should be infrastructure as code in the cloud. And at Amazon, they have a framework for that too. It provides VENs with pre-made templates, either CloudFormation or CDK. That's what they prefer at Amazon. I know there's another option out there, but they don't use it that much. And these templates are vetted. They're vetted for security purposes, and they're vetted to be well architected. So teams can make use of that. Again, less reinventing the wheel. All right, so that's the Amazon use cases I wanted to show you. Now I want to show you a bonus use case, which is not Amazon. And it's about disaster recovery. We saw that in the previous slide. So to talk about disaster recovery, I think first I need to give you the big picture of resilience, right? So in terms of resilience, we tend to think of it as three broad categories: high availability, disaster recovery, and continuous resilience throughout all of that. So chaos engineering falls under continuous resilience, continuous improvement, right? High availability is about the everyday, smaller scale things like a server dying that you can fix in place. So disaster recovery is different. Disaster recovery is about the big scale, less often, but big scale faults, major issues, major outages, like a natural disaster or a major technical failure, not a little power outage, but a big power outage. Or another technical failure is when a faulty service is deployed to a region, a cloud provider's region, or a network goes down in a cloud provider's region. That'd be another technical failure. And then human actions. These are the ones that often get overlooked when you're talking about disaster recovery. This is a person who accidentally drops your tables, right? That's a disaster. But there's not only accidents, there's also malicious actors out there. And that's where ransomware comes into play. And ransomware is a type of disaster too. It requires a few more mitigations on top of normal disaster recovery mitigations, but it's another form of disaster. So disaster recovery is those kinds of faults typified by that you can't recover in place. You have to fail over to a good region. And instead of being measured like high availability is by the nines, it's measured by the recovery objectives, RTO and RPO, recovery time and recovery point, which is about recovery of your data. Okay, so now given that I've explained what disaster recovery is, this is a blog post I wrote, if you want to snap the QR code there, several years ago about how to back up and restore your infrastructure and data, right? And in it, I explain how AWS gives you the tools you need, okay? Are you using an EBS volume? That's block storage. AWS Backup, which is an awesome tool, lets you back that up across regions, and then you can recover it. That's what it shows here. It's restoring the data from backup. You have an EC2 instance and other infrastructure you need to recover. Hey, infrastructure as code to the rescue. You can use your CloudFormation template to redeploy that EC2 instance. But what you're looking at here is not a functional application, right? That's not a functional. I have a blob of data and a running server, and they don't know each other exist, right? Back home, back in the original application before we failed over, they were probably that EBS volume was attached, that EC2 instance, right? And that EC2 instance was running code. So let's take a look at that. In the same blog post, I say, oh, no problem. Here, this is all you have to do. First of all, AWS Backup emits events. Well, set up EventBridge to listen for those events. When EventBridge sees that you've recovered your EBS volume, have it call Lambda. That Lambda will run automation code, which will look for that EBS volume that you just told it about and look at the metadata on that volume. Based on the metadata on that volume, it'll find the EC2 instance that CloudFormation has already set up and find the matching metadata. Then it'll attach them, and then it'll emit a ops center event. Easy, right? Right? Well, I mean, in the blog post, I actually say this is possible, right? This is something you can do, and it certainly is. That was two resource types, an EC2 instance and an EBS volume. How about reality? So Choice Hotels, in their shopping and booking application, has 45 or more resource types. And yes, each one of those icons is actually a resource type they're using. And yes, maybe I can name what those icons are because I just put them in the slide, but don't ask me in a week. Even though that doesn't add up to 45. And for enterprises in general, that's just one workload. It gets even more difficult, right? Across the shopping and booking application for Choice Hotels is actually 14,000 total resources. So 45 resource types instantiated as 14,000 actual objects, both data and infrastructure. And the shopping and booking application is actually split across multiple services, each running in their own AWS account. So it gets complex. And this is only one of many applications. Besides shopping and booking, they have loyalty and third-party integrations and all kinds of applications that they need to be able to be disaster resistant. And I mentioned infrastructure as code as a solution. Well, I'm not blaming Choice here. A lot of companies have this issue where their infrastructure as code has sort of grown organically. It's not great for restoring infrastructure in another region. It's just, it might be multiple templates per service, or it might not be totally well aligned to services, or there's complexity there. And finally, they want it to be a ransomware solution in addition to a disaster recovery solution. So it should be cross-account, right? If you have your disaster recovery solution cross-region in the same account, guess what? The bad guy is already in the account. That's not going to help you. Going cross-account helps protect you there. Okay, so frameworks to the rescue, right? So we want a framework that can make use of the native tools, right? That's AWS Backup. Instead of using infrastructure as code, we'll use the AWS API to set up all the infrastructure and the pieces. Snapshots, we use step functions, which is a state machine to orchestrate it. On the far right, note I have guard duty and security groups. That's going to come in handy when you have ransomware recovery, right? You recover in another account and you use security groups to quarantine those resources and guard duty to do the forensics on them. So using a framework, you can back up and recover all of these resources, not one at a time and have to stitch them together, but as a whole service, a whole application. And this is where my current employer, RPO, comes in. So RPO is about not just backing up your data and your storage, but also the infrastructure and the network and the identities and the configuration and all the connective tissue in between. So when you actually go to that orange arrow that says recover everything, everything comes up. And it looks like this for Choice. So Choice has their shopping and booking app. It's deployed across multiple AWS accounts. That's what those pink boxes are, AWS accounts. And guess what? There's a problem in whatever region they're operating out of. They're down, right? Well, if they're using RPO, they can literally hit a button that will restore everything across all those different AWS accounts and stitch it together so it just works and comes back up in minutes. So frameworks to the rescue. Okay, well, I appreciate you being here for DevOps in the Cloud. I talked about case studies of Amazon teams and the resilient architectures and two pizza teams and how two pizza teams own everything end to end. We talked about the detail page and buying experience. We talked about Amazon Search and their chaos engineering journey. And we talked about the Relay app and Builder tools. And the bonus, I gave you a little bit about Choice Hotels and the disaster recovery with RPO. These resources are here in case you want to learn more about any of the stories I told. You want to learn more about Amazon Search or more about Relay app. I have blog posts and videos all about those. So I assume you get a copy of the slides afterwards, so they'll be there, or you can take a picture now. Please remember to fill out your surveys. It's in the app. If you haven't already installed the app, it's called Event Mobi, and that you'll need that password to get to the event. But I would appreciate your feedback. There's contact information for me, and I actually have time for questions.